Chemical properties of alkanes. In this case, we will be talking about 7 properties. You need to remember 7, okay, headings so that you can recall. Substitution reactions, combustion, controlled oxidation, isomerization, aromatization, reaction with steam, and the last one, pyrolysis. One by one, I would suggest that you just pause the video here, memorize all 7 headings so that you can recall. Substitution reactions. Substitution reaction means the hydrogen is replaced by halogen. The hydrogen of alkane will be replaced by halogen. Normally it is preferred for chlorine and bromine only, because with fluorine the reaction is too violent. We don't have easy mechanism to control the rate of the reaction, and with iodine it is reversible. So there is workaround. I will be talking about, we can use it for iodine as well, but mainly preferred for chlorine and bromine. So what happens, that one by one hydrogen will be replaced. Hydrogen of what? Hydrogen of alkane will be replaced by chlorine or bromine, that is halogen. It happens in presence of sunlight. So what happens? Suppose CH4, this is the alkane. We are getting it reacted with chlorine in presence of sunlight. H nu represents sunlight here. You know H nu 1 quantum. Okay, we have talked about it in structure of atom. So first one hydrogen is replaced, then another hydrogen is replaced, then another hydrogen is replaced, and ultimately all hydrogens are replaced and we get carbon tetrachloride or tetrachloromethane. The rate of reaction is fluorine, very fast reaction, so that's why we don't use it. Then chlorine, bromine, iodine is very slow, so slow that it is almost reversible reaction with iodine. And here it is too fast, that is violent, we can't control it. But if we talk about in terms of whether we have secondary carbon, tertiary carbon, primary carbon of the alkane, the hydrogen will be replaced fastest from tertiary carbon, then from secondary, then from primary. You must remember these orders. The reason is you get frequent questions on arrange these in the order of reactivity. Okay, so for that you must know the trend. So this is decreasing order. Remember, decreasing order, right? All in both the cases it is decreasing order of reactivity. Fluorination is too violent. This is something I have talked about. Okay, so to be controlled, we don't use it. Iodination is very slow and reversible, but there is a workaround. We can actually make it only forward reaction. We will use oxidizing agent like HiO3 and HNO3. So what will happen? First understand what will happen in case of iodination. In case of iodination, suppose if I am taking same example of CH4, but now I am using I2, it will give you CH3I and HI, right? Now if this reaction is reversible, this is like this. Okay, we can stop the reverse reaction if we can remove the products or any one of the products. What we do in this case, we get this reacted with either HiO3 or HNO3. They oxidize HI. So what happens? This HI is not available because this has been consumed by either HiO3 or HNO3. So reverse reaction will not happen. Only forward reaction will happen, and that will increase the rate of reaction. So CH4 plus I2 will give you CH3I and HI. This HI will be oxidized to iodine by either HiO3 or HNO3. You can use any one. And you can see this is oxidation because here iodine has oxidation state -1. Okay, halogens in their hydrogen halides have oxidation state -1. And here iodine in its elemental free state form will have oxidation state 0. So -1 to 0, it is increase in oxidation state, that is oxidation. Mechanism of halogenation, this is asked in 2 marks question. Okay, very easy one. You just need to understand the pattern. Halogenation involves free radical substitution. If you write this one, 0.5 marks you get. Okay, whether it is based on formation of carbocation, whether it is carbocation driven, whether it is free radical driven. So that's something you need to remember. Free radical substitution reaction. And there are three steps I will be talking about in mechanism of halogenation. The first one is initiation, the second one is propagation, the third one is termination. Means first the reaction is started, then multiple steps happen here, multiple steps in propagation, and then it comes to an end. Again, there will be certain reactions which will bring the main reaction, that is the chain reaction, to an end. How it happens? First is initiation. So in the beginning, what happens? That homolysis of the halogen takes place. So reaction does not happen initially. In the initiation part, reaction starts by homolysis, and in homolysis, you know, free radicals are produced. In homolysis, free radicals are produced. So chlorine, for example, if we take, 2 chlorine free radicals will be produced. Then propagation will take place. Here the reaction will start, propagation. So this chlorine free radical will react with alkane and will give us methyl free radical now. And this trend you need to understand. In all the steps of propagation, what will happen? One free radical will react with non-free radical. Okay, in all the steps of propagation, you will notice that. So now we have obtained methyl free radical. It will react with another non-free radical. And non-free radical is chlorine. So methyl free radical now reacts with chlorine, gives us methyl chloride and chlorine free radical. So this trend is continuing. On left hand side you have one free radical, one non-free radical. On right hand side also you will have one free radical, one non-free radical. Okay, means normal molecule. Now what will happen after this one? These are the two steps we have already talked about. Okay, these are the two steps. First, from chlorine free radical we got methyl free radical. Okay, so what will happen here after that one? After that one, again free radical will combine with non-free radical, non-free radical will combine with free radical. So this will repeat, this will keep on repeating. That's what I have written here. Okay, so now we have CH3Cl here, and this is the free radical. Both will combine and they will give us CH2Cl and HCl. Basically every time what's happening, one free radical and non-free radical is combining to give you free radical and non-free radical. That's it, what's happening. Okay, so in such cases where the products will react, remember the products will react. In this case the pattern will be that the free radical will get transferred to other one, hydrogen will get attached to this one. This will be the case. Okay, free radical will get transferred to the other one and hydrogen will get replaced. So this is in the first step also. If you note here, free radical got transferred here, hydrogen came here. So in alternate steps it will happen. So this is the alternate step. After skipping one, free radical gets transferred here and hydrogen comes here. Okay, now what will happen? The free radical here will combine with chlorine. So this part will repeat now. This part will repeat after that one. Okay, so this free radical produced will combine with chlorine. So in this case what happened here, same thing will happen here. Okay, so in this case chlorine will get attached here, hydrogen will get attached here. No, in this case what will happen? Chlorine will get attached here. Okay, and this part will create another chlorine free radical, right? Now again this part will repeat, means these two will combine, and when these two combine, what will happen? The free radical will be transferred to the left side. So free radical will be transferred here and hydrogen will come here. Then again next step, This free radical will combine with chlorine. Chlorine will get divided. One part will give you chlorine free radical, and the other part will get combined here. Then again these two will combine. Okay, when these two combine, this free radical will be transferred here. Okay, and hydrogen will get attached with chlorine. So this free radical got transferred to CaCl3 and hydrogen combined with chlorine. We got this one. Now this one will again react with chlorine. So chlorine, here division will take place. This part will give you chlorine free radical. This part will combine, will give you CCl4. That is the last part. After that, you don't have any hydrogen here to be replaced. Till now you had hydrogen to be replaced from the compound to be produced. Okay, but now here you don't have any hydrogen to be replaced. So here you had hydrogen, here you had hydrogen, here you had hydrogen, but now all hydrogens have been replaced by chlorine. How the reaction comes to an end, that is now the termination step. In termination, if you see, I'm just going back, if you see what are the components which are responsible for propagation of the reaction. So propagation of the reaction, this part is taking place. Okay, this part, okay, propagates the reaction. Now if these are not available, okay, this chlorine free radical, methyl free radical, if these are not available, the reaction will not propagate, the reaction will stop in that case. Okay, so what can happen? There are three possibilities. This chlorine free radical can combine with methyl free radical and will produce CH3Cl, and they will not be available. In that sense, they can get consumed. Or chlorine free radical can combine with chlorine free radical, can give you Cl2 also. So chlorine free radical will not be available. In that case, the reaction will stop. Or methyl free radical can combine with methyl free radical, can give you ethane. In that case also the reaction will stop. So all these three are the termination steps. Either chlorine free radical will combine with itself to give you chlorine, so chlorine free radical might not be available for propagation of the reaction. Methyl free radical combines with methyl free radical, will not be available for propagation. Methyl free radical combines with chlorine free radical, and then not available for propagation. So these three steps will ultimately bring the reaction down, or can bring the reaction down in few cases, even if few methane is still there, right? The reason is that before we get CCl4, sometimes all the free radicals can combine, means this one which is being used can combine, and the methyl free radical which was produced in first step, that can also get combined. And ultimately, obviously, these are the reactions which will bring the propagation to an end. So these three reactions you need to remember, which will terminate the process. This question appears in 2 marks. Combustion one, this is something I have been talking about again and again. There is a generic reaction we have already talked about, that when CXHY, any hydrocarbon reacts with X plus Y by 4 times oxygen, it gives X times CO2 and Y by 2 times H2O. This is something we have been talking about in terms of X and Y. Now this reaction can be modified, because normally for alkanes we write CnH2n plus 2. We write it like this, means here X is N, Y is 2n plus 2. So if you substitute X by N and Y as 2n plus 2, then you get this reaction, this one, second one. I suggest you memorize both. The reason is because if you substitute these values, X as N, Y as 2n plus 2, and then get the reaction, it will waste time in exam. These are the generic reaction, and obviously it is combustion. When hydrocarbons react with oxygen, when they are brought to the ignition temperature, so that's why heat is written there, then they start burning, so that is combustion. Example, CH4 plus 2O2 will give you CO2 and 2H2O. The heat released, it is negative. Okay, so combustion obviously is exothermic process, it gives us a lot of heat. Combustion of hydrocarbons, remember hydrocarbons, butane, so LPG is normally butane. Okay, primarily it is butane gas, LPG liquefied, okay, in the form of liquid. CNG, natural gas is methane, this one. So when it burns, it gives us 890 kilojoules per mole. C4H10, as I said, that is LPG. When it burns, it gives us 2875 kilojoules per mole. During incomplete combustion, now, if the combustion is incomplete, means the oxygen is not available in sufficient amount. In that case, incomplete combustion will take place and we will get carbon. So this is actually responsible for soot particles. Okay, soot particles as pollution from vehicles. So sometimes not entire petrol or diesel is burnt, so incomplete combustion takes place, and that's why in exhaust we get carbon particles which are known as soot particles, and when they combine with the dust, etc., they lead to pollution. Controlled oxidation. Now this one is that if you can control the number of moles of oxygen in different conditions, different products will be produced. So you can have same hydrocarbon and oxygen with different amount of oxygen, you can get different compounds. For example, methane reacted with 1 mole of O2, 2 moles of methane reacted with 1 mole of oxygen in presence of copper at 523 Kelvin, 100 atm. So conditions are obviously very important, otherwise you won't get the compounds. Sometimes it is written that when the methane is passed through copper pipe also. Okay, red hot copper pipe. Obviously at 523 Kelvin, the copper will be red hot. What will be produced? Methanol will be produced. So in this case, alcohol is being produced. Second one. Now it is 1:1 ratio. Here it was 2:1 ratio, 2:1 ratio. Now it is 1:1 ratio. In presence of molybdenum oxide heated, we get methanol, formaldehyde, methanol. So different compound. Remember, we are using same reactants, methane and oxygen, but in different proportions. The third one, now we are using ethane and oxygen. In presence of manganese acetate heated, we will get acetic acid. So in this case, we will get acetic acid, ethanoic acid or acetic acid. 3 different reactions depending on what is the amount of oxygen. So here ethane and oxygen ratio is 2:3. 2:3. You should remember these reactions. Ordinarily, alkanes resist oxidation, but alkanes having tertiary hydrogen atom can be oxidized to corresponding alcohols by potassium permanganate. This reaction is important, and remember here you can't have secondary or primary alkane. So if you say you have CH3, CH3, okay, CH2, CH3. Here this is 2 degree carbon, this is 1 degree carbon. So this reaction will not happen. It will proceed to just 4-5%. So we say that reaction will not proceed. But if we have 3 degree, this one, okay, this is CH3, CH3. This is 3 methyl groups attached to 1 carbon. Okay, so these 3 methyl groups attached to 1 carbon. In this case, if we use KMnO4, remember KMnO4, K2Cr2O7, CrO3, all these are oxidizing agents. We will be using these in organic chemistry, even in 12th, IIT, NEET, etc. So you need to remember KMnO4, K2Cr2O7, CrO3, all of these are oxidizing agent. Then this hydrogen is oxidized to OH, means we get alcohol. So from tertiary 3-degree alkanes, we can get 3-degree alcohol by using KMnO4. For 1-degree, 2-degree also you can get, but the method is different. You will have to first convert it to halide and from halide to alcohol. That's also easy. Isomerization means it is same formula but different structure. So N-alkanes isomerize to branched chain alkanes in presence of anhydrous AlCl3 and HCl. So isomerization, whenever it comes to your mind, you should be able to recall we are talking about anhydrous AlCl3 and HCl. Then isomerization will take place. So if it is N-hexane, N-hexane means it is CH3, CH2, 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 CH3. It will get converted to say 5 carbon main chain, CH3CH, CH2, CH2, CH3, and the other one is here, CH3. Okay, on this carbon. Branch can be on this carbon also. Okay, so if that is the case, it will be CH3, CH, CH2, CH2, CH3, branches here. Remember, if you have branch here, it is same thing as this one. Okay, so having the branch on right hand side on second carbon or left hand side second carbon, it is same thing. So you won't write this one as a separate or different compound. It is same thing, because the numbering will start now from the right hand side, because branch is nearer to right hand side. Then aromatization, very important reaction, and there are very few reactions where we can convert an aliphatic compound to aromatic compound. This is also known as reforming aromatization, because we are converting non-aromatic, that is aliphatic compound, to aromatic compound. So what happens? We take N-hexane. This is just one example. There can be other reactants also. So we take N-hexane. I have just written it in this form because it is taking the form of a ring. Otherwise, this N-hexane is simply CH3, CH2, 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 CH3. Right? I have written it in ring form. So what happens if we pass this through chromium oxide, vanadium oxide, or molybdenum oxide at very high temperature, 773 Kelvin, and high atmospheric pressure, 10 to 20 atm. It's not very high atmospheric pressure, it is just high atmospheric pressure. Then this ring will form. Okay, and it will become aromatic. That is, the double bonds will appear here, here, and here. Double bonds will appear. It will be CH2 and CH2 then. That is benzene, and benzene is aromatic compound. So conversion of N-hexane to benzene can be done from here very easily. Okay. Now the question, which is based on previous concept, suppose you want to make toluene. Okay. Toluene formula, you know, toluene is benzene, and on that you have methyl group attached. This is toluene. Now the question is, by using same concept, that is Cr2O3 or V2O5, okay, and obviously 773 Kelvin and 10 to 20 atm, what we should use here so that we get toluene? The answer is again very simple. Okay, just write what we had done there: CH3, CH2, 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 CH3. Now if you think that I add here CH3, I make it CH2, that will give me the answer. No, that will not give you the answer. Okay, that will not give you the answer, because here it is being attached. Rather, you should have CH3 on any other carbon here. So this will give you the toluene, because this part will combine and this CH3 is extra. Now this CH3 can be anywhere except the ends. It can be here also, it can be here also, okay, anywhere. So there are total 3 possibilities. It can be here, Okay, it can be here 1 2 3 4 5 6. Okay, there are two possibilities, not three. Okay, now why I am saying only two possibilities? The reason is, if it is from this end, if it is here and here, it is again same thing. The numbering will start from now the right hand side. Okay, the numbering will start now from here 1 2 3, because the branching is nearer to this side. So anyway, it can be on either 2 or 3, second or third carbon. So there are two possibilities. You can have either 2-methyl hexane or 3-methyl hexane. Both will give you toluene. Okay. Very common question it is asked. Next, sixth one, reaction with steam. Normally, alkanes will not react with water. They are insoluble in water. The method is used for industrial preparation of dihydrogen gas. So we get it reacted with steam, not with just water, steam. So methane, when reacts with steam in presence of nickel, it gives us carbon monoxide and hydrogen. So this is industrial method, cannot be used in laboratory, and the reason is very simple. Carbon monoxide being produced, we can't produce it in the laboratory. We have to take care of the carbon monoxide. It is poisonous gas. So that's why it is used for hydrogen only. Pyrolysis. Pyrolysis, whenever you see this word pyro is related to fire. Okay, fire. P for pyro, P for pushpa, fire. Okay. Higher alkanes on heating to high temperature decompose into lower alkanes. Means if you heat, if suppose there are 7 carbons, 8 carbons in the alkane, if you heat, lower carbon alkanes will be produced or alkenes will be produced. So might be if you have N-hexane, it will give you propane. Okay, hydrocarbons having less number of carbons. So here you have hexane at 773 Kelvin. It can give you the hexene and hydrogen. So less number of carbon and hydrogen here. Carbon same, hydrogen less. Here you have butene rather. This one is butene, and here you have ethane. So it can get split into multiple ways, whatever is the possibility. Okay, so if you have C6 here, it can get split into C4 and C2. It can get split into C3 and C3 compound, means compound having 3 carbons, here compound having 4 carbons, here 2 carbons. Or it might be possible you can have just 1 carbon and 5 carbons. So whatever are the possibilities, or there is a possibility you can have 3 carbon, 2 carbon, 1 carbon. Okay, some should be 6. So there are multiple possibilities. This process is known as pyrolysis. Higher alkanes getting converted into lower alkanes or alkenes. This is also known as cracking. Now this is slightly tricky also. Both are actually synonymous. Sometimes it is asked pyrolysis is known as, you will write cracking. Sometimes it will be asked cracking is known as, you will say pyrolysis. So if it is asked pyrolysis of ethane is called, if the option is cracking, you will write cracking. If it is written cracking of ethane is called, if pyrolysis is option, you will select that.